Grade 10s. Here we go as we continue talking lines. Hopefully a little bit shorter lesson. We're going to talk and use slope, but we're going to use slope now to create lines and how they relate as opposed to just getting slope from lines. So remember, slope we can call rise over run, which is the change, rise in our vertical, our y values over run horizontal, change in our x values. We can calculate it by getting the difference between our y values over the difference between the two x values of 2 points. That's what slope is. That's how we calculate slope. Let's take a look at how we can use slope. First thing that's important is to understand that slope is a set of directions, kind of how I look at it, to go from a point to on a line to a second point on the same line. Take a quick look at an example. I know it's not in the booklet, but if I have a slope of 7 over 8, well, remember, the rise is the vertical change. So what does that 7 tell us? Well, the 7 tells us, positive 7, that we're going 7 up from a point. The 8 is the run or the horizontal change. And the horizontal change, because it's positive, is telling us it's a horizontal change to the right because it's positive 8. So if I'm at a point and I start at any point, doesn't matter where the point is. This point could be anywhere. But a slope of 7 over 8 is telling us to that point we can go 7 up to here and then 8 to the right. And there's point 1 and a rise of 7, a run of 8. There's the next point and I can create the line. So it will work for any point. If this was my first point, again, it would be a rise of 7, a run of 8. There's the point. However, what's really, really important to understand that a slope of 7 over 8, how else can I make a slope of 7 over 8? It's a positive slope. Don't forget that to create a positive 7 over 8, we could have started with negative 7 over negative 8. Those are the same thing because two negatives make a positive. So if I have a slope of 7 over 8, here's one set of directions, but 7 over 8 could also be thought of as negative 7, negative 8. I can get a second set of directions from that. Negative 7 rise would be 7 down. And negative 8 as my run would be 8 because it's negative to the left. Well, what would that do? Well, this second thing that I showed, again, if I started at this point, I could say it's 7 up, 8 to the right for 7 over 8. But negative 7 over negative 8, that would be saying go 7 down and 8 left. I would still end up on the same line. Little bit different set of directions for the same situation. So understand a slope, because it's telling you vertical movement and horizontal movement, it's giving you directions from point to point. So if we take a look at page 8 and those 4 slopes, what are the directions that could get, what kind of directions is this giving us? Well, a slope of 2 over 3, rise of 2 would mean up 2. Run of 3 would be right 3. So if I had a point, any point, I could go up 2, and right 3. And there would be a new point. But don't forget, what's the same as negative or 2 over 3? Well, what else makes a positive? Negative 2 over negative 3. What would these directions be? Negative 2 would be 2 down. Negative 3, run, would be 3 left because it's negative. And that means from my original point, if I went 2 down and 3 to the left, there's my point, and I see that those 3 are still in line. Now, if I was on a Cartesian grid, it would be even more perfect. You would see it specifically, but every slope has a partner. Don't forget about that. Let's skip to m equals negative 8. Now, here's a problem because we don't have a rise over run. What can I always do with a whole number, though? A whole number can always go over 1. So negative 8 is the same as negative 8 over 1. What do these directions tell me? We have a rise of negative 8. And that means rise of negative 8 is actually down 8 because it's a negative vertical change. And the run of 1, because it's positive, the negative is on the 8, the 1's positive, that would be right, because right is positive for the run 1. So again, if I had some point, it doesn't matter where the point is, I would do down 8, right 1. 1, 2, 3, 4, 5, 6, 7, 8, and right 1. And what do I notice? Well, if I connect those 2 points, connecting those 2 points means it's a downward slope, which means it's a negative slope. However, what's the same as negative 8 over 1? Well, how else can I make a negative slope? Well, I can just put the negative down with my run. Because 8 over negative 1 is still a negative slope, but my directions now, my rise would be 8 up, and my run, negative, would be 1 left. So if I went back to my original point, if I went up 8, 1, 2, 3, 4, 5, 6, 7, 8, and 1 to the left, look at that. These 3 points are lined up. So every slope I have gives directions, but every slope has a partner slope that also gives directions, but still creates the same line, and that's what's important. You have 2 more there, 12, 7, negative 7, 8. Stop the video. Give those 2 a try. See what you come up with. 2 sets of directions. And then let's do them together. All right, so we have, for this case, slope of 12 over 7. What's the second possible slope? What else gives a slope of 12 over 7? Negative 12 over negative 7, because 2 negatives make a positive slope. This rise is 12 up. This positive 7 is 7 to the right. Having the slope written the same way is another way to get directions. What does my negative 12 rise say? That'll be 12 down. What does my negative 7 run say? That'll be 7 to the left. 2 sets of directions for that slope. Last one was a slope of negative 7 over 8, which would also be a slope of 7 over negative 8. 1 negative means it's a negative slope. Here the negative's on the rise, here the negative's on the run. What does this tell us for directions? Rise is negative, so it would be 7 down. Run is positive, so it would be 8 to the right. Those directions will get us to another point. These directions will get us to another point, a different point, but still on the same line. Rise of 7 would be 7 up. Run of -8 would be 8 left. So slopes give us directions. Now let's utilize that information. We want to draw a line that passes through point -3, -3, and has a slope of 2, 3. Well, the first point is our first step. We want to plot that point. -3, -3. There's C. There's our starting point. Now we have a slope of 2, 3. What do those directions tell us? Rise of 2 will be 2 up. A run of +3 will be 3 right. So from my point, initial point, is I now move that slope. So I'm going to go up 2 and right 3. There's a point. How would I get to the next point? Well, they still have the same slope. Up 2, right 3. There's another point. Up 2, right 3. There's another point. The more points I put, the more specific I can be when I draw my line. But what's another slope that's the same as 2 over 3? -2 over -3. What does that tell me? My rise is negative, so it would be 2 down. My run is negative, so it would be 3 left. Well, what happens when I go 2 down and 3 left? Look at that. I'm still in line. 2 down, 3 left. And I can now connect those points to create my line. Given one point C, I can draw that line simply by moving the slope. As many points as I want to put. The more I put, the more precise I am. Try this one. A little bit different because of terminology. You're given point P at the origin. So at the origin means there's P. There's where we're starting. And now we have a slope of -4. Well, a slope of -4 can be written over 1, remember. So what do these directions tell us? Rise of -4, 4 down. A run of +1, 1 to the right. So that point, I can go 1, 2, 3, 4 down, 1 to the right. 1, 2, 3, 4 down, 1 to the right to get to the next. Because they all have the same slope. And if I look at that, just for those points to start, it's going down as we move to the right. It's a negative slope, and it's going down as we move right. What's the other slope that will work here, though? 4 over -1 is also a negative slope. What do those directions tell us? A rise of 4 is 4 up. A run of -1 is 1 left. So from my original point, I can go 4 up and 1 left. 4 up and 1 left. And I see those points are still all lined up to create the line. Slope is steepness. It's the direction, but it's directions of going from point to point. Now, we do have some questions that sometimes we can use slope that make you think that aren't totally straightforward. We want to find the value of K, because we know we have point K, 5, but we don't know what K is. But we know it's along the same line with this information. So if I put this information on the graph, I should end up with a point somewhere on the x-axis, because I don't know what it is, but it's going to be 5 up. So how do we do this? Let's start with 4, 2. 1, 2, 3, 4, 2. There's my P. And now I want to move a slope of 3, 5, or negative 3, negative 5. So 3, 5 would be 3 up, 5 to the right. Or it would be 3 down, 5 to the left. There's my line. I can connect that, and there you go. But the question is, do I now have a point at K5? Well, we're not sure along the x-axis how far we go, but we know we want to be 5 up. There's my 5 for my y value, and there's the point that it matches with. So my K5 point tells me how far over are we? 1, 2, 3, 4, 5, 6, 7, 8, 9. So K is equal to 9. Using the knowledge of lines. Now this same question though, it tells us algebraically figure that out. Algebraically using the slope formula. Well, what do we know in this case? We know that we have a slope of 3 over 5. But we calculate the slope using 2 points. We know we have point 42, and we also know we have this point that's K5. How do we calculate slope? Remember, slope is change in y's over change in x's. So let's start with that. What's the change in my y's? Well, 5 minus 2. 5 minus 2 is the change in my y's. Well, it has to go over the change in my x's. If I'm going to go 5 minus 2, I have to have k minus 4. Because the 5 minus 2 would be over k minus 4. But what does this calculation give us? Well, we know the slope is 3 over 5. So there's the information we want to utilize. When I take a look at this, 5 minus 2 equals 3. So right away, perfect. We have 5 minus 2 equals 3. That's what we want. And that has to be over k minus 4 equals 5. Well, what minus 4 equals 5? Well, k has to equal 9. And there you go. We can use the slope calculation, knowing what our slope is, to calculate the unknown. So, example 4, same page. Give these a try. Stop the video. Same kind of question. See if you can come up with x on the graph, and see if you can come up with x algebraically. Give it a try on your own, and then we'll talk. All right, here we go. So we have a line through 3, negative 2, and a slope of 2, 5. So 2, 5, what's the directions? 2 up, 5 right, positive, positive. We could also use negative 2, negative 5, because 2 negatives make that positive slope. That would be 2 down and 5 left. So I'm going to put some points on. 2 up, 5 right. Or 2 down, 5 left. We want another point at x negative 4. So we say x negative 4, we know our y has to be negative 4. There's negative 4, there's the point. And what's the x value? X is negative 2. Because these 3 points I was able to create passed through the point that we needed. At x negative 2, y negative 4, so x is negative 2. On the graph, visual, kind of nice. Algebraically, little trickier. know what you're working with. What do we have? We have a slope of 2, 5. We have a point, 3, negative 2, and we have a second point, x, negative 4. Well, let's use all of this together with the slope formula, knowing change in y over change in x. Well, what are we going to do? Negative 4 minus negative 2. That's what I'm using for my change in y's. What would I do for my change in x's? Well, if I'm going to go negative 4 minus negative 2, I need to go x minus 3. And that calculation should equal my slope of 2 over 5. So, when we do this though, this one's not going to work out for me this way quite as nice. Because negative 4 minus negative 2, that equals negative 2. So this calculation up top equals negative 2. Well, what would my bottom calculation have to be so that I end up with a slope of 2 over 5? Because our calculation has to be 2 over 5, but my first calculation was a negative 2. Well, if I had a negative 5 on the bottom, negative 2 over negative 5 is what we need. So I need my x minus 3 to be negative 5. So x minus 3 has to equal negative 5. In order to end up with negative 5, what's my x value so that I finish there? Well, I can solve for x by adding 3 to both sides. And negative 5 plus 3 is negative 2. So my x would be negative 2 with my y, which is negative 4. So x is negative 2, which is the same thing as it was on the graph. Slope calculation, slope on the graph, it's the exact same thing done a little different. Now, we talked, if we go to page 10, the fact that rate of change and slope are really the same thing. Because if you recall from last unit, rate of change was the change in our y over the change in x, which is exactly what slope is. It's the same thing, but just different terminology. Rate of change is nice for real world situations, which we did a lot of at the end of last unit. Slope is a term that gets used just if you want to do math, not real world applications. So for our graph here, first thing is determine the rate of change. Well, rate of change in y, change in our dependence, over change in x, our independence. Point to point, what's our vertical change? We're going from 20 to 80. The change is positive 60 because we're going up. And our horizontal change, well, 1, 2, 3, 4, 5, these are all single values. So we're going from 1 up to 9. So from 1 to 9, horizontal change is 8. So 60 over 8, this is, y is kilometers, x is hours. So the rate of change is we're going 60 kilometers every 8 hours. If I were to divide this like we have last unit, 60 divided by 8, that would work out to be 7.5 kilometers per hour. There's what you're looking at for the rate of change. How does this compare to slope? Well, slope change in y over change in x. We're still change in y here to here. We're doing a change of 60 over a run of 8. It's still 60 over 8. Reduced is 15 over 2. Because slope doesn't deal with quote-unquote real-world problems, you would just leave slope as 15 over 2, but rate of change for the situation, whatever it is, something is moving 7.5 kilometers per hour, which is the same as a slope of 15 over 2. Slope, rate of change, same thing. So page 10, now talking about Thomas. Thomas earns $77.50 for 5 hours of work at his job in the summer. What's his rate of pay per hour? Well, $77.50 divided by 5 hours, he's making $15.50 per hour. That's the rate of pay per hour or rate of change. It's the consistent amount. In the first hour, he would make $15.50. In the third hour, that third hour of work, he would make $15.50. But if I were to track it for total income, 1 hour would be $15.50. After 2 hours total work, well, it would be $31. After 3 hours, it would be $46.50. 4 hours would be $62. 5 hours would be $77.50. But this is because every time the hour goes up by 1, what do we see? His income goes up by $15.50. So there's the rate of change. Because what's the slope of the line? Slope is rise, change in y, over run, change in your x. Well, if I look at the chart that I just did, what's the change in my y? Remember, there's your dependent. The change in y is $15.50. And what's the change in my x or independent? Well, it's a change of 1. So that is $15.50 per hour, whether you write it as rate of change or whether you write it as a slope. Slope and rate of change, exact same thing. Last example. Here we go. Chart is given for us. For 20 hours of work, you were paid $280. For 32 hours work, you were paid $412. So that's been put on here. It shows us this point here is saying 20 hours of work because hours worked is your independent. That's what changes, but your pay is what's dependent. So for 20 hours, you were given $280. And this one tells us that for 32 hours of work, you were paid $412. There's the information, and there's a line that can get created. What were you paid per hour for the hours between 20 hours and 32? Well, per hour, again, is the rate of change, which is change in y over change in x. So what can we do? Change in y, 412 minus 280 over change in our x. Be consistent. 412 minus 280 means our y is 32 minus 20. And 412 minus 280 and 32 minus 20 gives us 132 over 12 dollars per hour, $132 for 12 hours work, which when I divide those in a more reasonable sense is $11 per hour. So we know it would be $11 per hour. But we started with this initial amount we see. Our y-intercept tells us that you started with $60 for doing no work, just for showing up. So if I want to determine my salary for 46 hours, well, I can just look at the chart. We see this dotted line here starts for 46 hours. So if I go 46 hours and I go up to my line, here it is, and I go across, how much are you being paid? Well, we don't know if it's specific. That's why we like to use the word about $570. What's your fixed or base salary? And that's what we just pointed out. Without doing any work, your base salary is $60 to start without doing any work, which is represented by your y-intercept. The y-intercept gives important information. And how many hours have you worked if your salary is $445? Well, again, here's 445 on the grid for money made. So now I can go over to my line. There it is. And go down. And that tells me how many hours did you work? Looks like a little under. We're not sure exactly because it's not a specific scale. So I would say about 35 hours. Relation. Still, slope can give us the rate of change, but the relation can still come from the graph. There's your assignment from the textbook. Again, not overly complicated, but you're only going to get good at it if you practice. Have fun.